Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first three parts of inequalities where I have covered the basics of inequalities, inequalities with modular sign, quadratic inequalities and so on. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to do some questions based on quadratic inequalities and inequalities of higher order curves. So let us start with today's video. Let us start with this question today. Find the range of values of x that satisfy the following inequality 2x minus 5 whole square greater than equal to 9. Well, before seeing the solution of each questions, I would request you to pause the video for some time and attempt these questions from your end first, and then to check the solution. So we need to find the range of values of x which is satisfying this inequality. There are two ways by which we can find the range of values of x which is satisfying this inequality. First, we can break this 2x minus 5 whole square into a minus b whole square formula, and then we can form a quadratic inequality, and then we can find its factors from which we can find the range of values. Or we can take this 9 to the left hand side, and then we can use the formula of a square minus b square, from which we can also find the range of values of x. So let us first break this 2x minus 5 whole square into a minus b whole square formula. We know a minus b whole square is given by a square minus 2ab plus b square. So this 2x minus 5 whole square can be written as 2x whole square minus 2 into 2x into 5 plus 5 square. And this is greater than equal to 9. So this would be 4x square minus 20x, and this would be 25, and we can bring this 9 to the left hand side. So 25 minus 9 will give us 16, and this would be greater than equal to 0. Now, since 4 is common in this quadratic inequality, so we can divide this whole inequality by 4. So this would be x square minus 5x plus 4 greater than equal to 0. Now, this is a quadratic inequality, and we know how to solve a quadratic inequality simply by finding its factors. So the two factors for this quadratic inequality would be x minus 4 and x minus 1. And this is greater than equal to 0. So now we have the two factors as x minus 4 and x minus 1. So to find the range of values of x, we can simply draw a number line and we can put the critical points here. So here the critical points would be plus 1 and plus 4. Now, if we take a value which is more than 4, in that case, this quadratic inequality would be positive. So we can put a positive here. And from the last video, we know that quadratic polynomial changes its sign at the critical points. So if for values greater than 4, this quadratic polynomial attains a positive value. So between 1 and 4, this quadratic polynomial would be attaining a negative value. In a similar way, for values lesser than 1, this quadratic polynomial would be attaining positive values again. So the range of values of x for which this inequality would be satisfied would be simply x belongs to minus infinity to 1, including 1, union 4 to infinity, including 4. So this is the range of values which would be satisfying this inequality. We can also solve this inequality simply by taking 9 to the left hand side. So in that case, this would be 2x minus 5 whole square minus 9, which I am writing it as 3 square. And this would be greater than equal to 0. Now we have a square minus b square form. So we can use its formula, which would be a plus b times of a minus b. So this can be written as 2x minus 5 plus 3 and 2x minus 5 minus 3, and this would be greater than equal to 0. So if we simplify this, this would be 2x minus 2 and this would be 2x minus 8 greater than equal to 0. Now we can take 2 common from this 2x minus 2 factor and 2 common again from 2x minus 8 factor. So in that case, this would be x minus 1 times of x minus 4 greater than equal to 0. Here also, we are getting two factors, x minus 1 and x minus 4, which can be solved simply by using the number line approach, and which will be giving us the range of values of x to be minus infinity to 1 union 4 to infinity. So for such kind of inequalities, either we can expand it using a minus b whole square formula and then we can find the factors, or we can simply use a square minus b square formula to find the factors from which we can find the range of values of x which would be satisfying the given inequality. Now let us see this question. Find the range of values of x that would be satisfying this given inequality. So here we have quadratic inequalities in p by q form, and we need to find the range of values of x which would be satisfying this inequality. Well, to find the range of values of x for such kind of inequalities, we can again use the number line approach. But first, we need to find the factors for these quadratic expressions. So when we factorize 2x square minus 5x minus 12, the two factors would be 2x plus 3 and x minus 4. In a similar way, the two factors for x square plus 6x plus 8 would be simply x plus 2 and x plus 4. And this is greater than equal to 0. Now we can draw the number line and we can put the critical points on the number line. So the critical points here would be 2x plus 3 equal to 0, that is x equal to minus 3 by 2. So let us put minus 3 by 2 to be somewhere here. In a similar way, the other critical points would be x minus 4 equal to 0, that is x equal to 4. So 4 would be on the right side of minus 3 by 2. So let us put 4 to be somewhere here. And x plus 2 is equal to 0, that is x equal to minus 2 will also be one of the critical points which would be on the left side of minus 3 by 2. So let us put somewhere here. And x plus 4 equal to 0, that is x equal to minus 4. So minus 4 would be on the left side of minus 2. So let us put minus 4 to be somewhere here. So we have plotted all the critical points on the number line. So now let us take a random point on this number line and let us see whether this whole expression would be positive or negative. Let us take a point which is greater than 4 and let us see whether this part would be positive or negative. So if we take a point, say x equal to 5, in that case 2x plus 3 would be positive, x minus 4 would be positive, x plus 2 would be positive, and x plus 4 will also be positive. So we can say that this whole part would be positive. So we can put a positive here. And we know that at the critical points, this sign will change. That is, between minus 3 by 2 to 4, this whole expression would be attaining a negative value. In a similar way, between minus 2 to minus 3 by 2, this expression would be attaining a positive value. Between minus 4 to minus 2, it will again attain a negative value. And for values lesser than minus 4, this expression would be attaining a positive value. But since we are interested in those values of x for which this expression would be greater than equal to 0, so the range of values of x would be simply x belongs to minus infinity to minus 4, excluding minus 4, union minus 2 to minus 3 by 2, excluding minus 2 but including minus 3 by 2, union 4 to infinity, including 4. We are not including x equal to minus 2 and x equal to minus 4 because at x equal to minus 2 and minus 4, this denominator part would be 0. But we are including minus 3 by 2 and 4 because in that case, this whole expression would be equal to 0, which would be satisfying this inequality. So this is the range of values of x for which this inequality would be satisfied. So for such kind of inequalities where we have quadratic expressions in p by q form, we can apply the number line approach. Now let us see this question. Find the range of values of x that would be satisfying this given inequality. So here we have mod of x square plus 5x plus 12 greater than 8, and we need to find those range of values of x which would be satisfying this inequality. Well, to solve such kind of questions, we need to have the knowledge of modulus sign and how we can solve questions of inequalities with modulus sign, which I have already covered in part 2 of the inequality topic, the link of which I have given above and also in the description box. So before seeing the solution of this question, I would suggest you to go through that video first and then to come back to this video. We know that if mod of x is greater than a, then x would be greater than a or x would be less than minus a. So let us use the same concept here. Mod of x square plus 5x plus 12 is greater than 8. So using this, we can say that either x square plus 5x plus 12 would be greater than 8 or x square plus 5x plus 12 would be less than minus 8. So if we solve this, this would be x square plus 5x plus 12 minus 8, which would be plus 4 greater than 0. And this will give us two factors as x plus 1 and x plus 4. And this is greater than 0. And we know how to solve such kind of inequalities. So we'd be drawing a number line and we'd be putting the critical points here. So here the critical points would be minus 4 and minus 1. And for any values of x which is greater than minus 1, this quadratic polynomial would be attaining a positive value. In a similar way, between minus 4 to minus 1, this quadratic polynomial would be attaining negative value. And for values lesser than minus 4, this quadratic polynomial would be attaining a positive value. So the range of values of x for which this part of the inequality would be satisfied would be simply x belongs to minus infinity to minus 4, excluding minus 4, union minus 1 to infinity, and again excluding minus 1. Now, for this part of the inequality, we can write x square plus 5x plus 12 plus 8, which would be 20, and this would be less than 0. Now, if you look here carefully, the discriminant for this quadratic part would be b square minus 4ac, that is 5 square minus 4 times of 1 times of 20, that is 25 minus 80, which is minus 55, which is less than 0. So that means there won't be any real roots which we can put it in the number line. So that means x square plus 5x plus 12 less than minus 8 is not possible. So the range of values of x for which mod of x square plus 5x plus 12 would be greater than 8 would be simply x belongs to minus infinity to minus 4 union minus 1 to infinity. So for such kind of quadratic inequalities with modulus sign, we can simply use these definitions to find the range of values of x which would be satisfying the given inequality. Also, discriminant of a quadratic equation, real or imaginary roots, etc. has already been covered in the quadratic equation videos. So in case if you are facing any difficulty in these parts, you can refer to those videos, the link of which I have already given in the description box. Now, let us see this question. Find the number of non-negative integer solution for this inequality. So we have been given an inequality x minus 3 raised to power 1000, x plus 4 raised to power 1001, x plus 8 raised to power 1002, x minus 6 raised to power 1003 less than 0, and we need to find the number of non-negative integer solution which is satisfying this inequality. Well, we have seen in the last video how we can solve inequalities of higher order polynomials, where we need to consider only those factors which are raised to some odd powers. Here, the factor x minus 3 is raised to some even power 1000, and the factor x plus 8 is also raised to some even power 1002. So when we'll be drawing the number line, we won't be considering the critical points from these two factors. But the factor x plus 4 and the factor x minus 6 are raised to some odd powers. So in the number line, we need to consider this x equal to minus 4 and x equal to plus 6 as the critical points. So if we draw the number line and if we put the critical points, that is minus 4, which would be somewhere here, and plus 6, which would be somewhere here. In that case, if we consider a value which is greater than 6, this polynomial would be attaining a positive value. So we can write positive here. Again, between minus 4 to 6, this complete polynomial would be attaining negative value, and for values lesser than minus 4, this polynomial would be attaining positive value again. So the range of values of x for which this complete polynomial would be lesser than 0 would be simply x belongs to minus 4 to 6. Since this polynomial is not equal to 0, so we would be closing this with open bracket. That is, x is not equal to minus 4 and 6. But at x equal to 3 and at x equal to minus 8, this polynomial attains a value of 0. And between x equal to minus 4 to 6, we have a value x equal to 3, which would be somewhere here. So we need to subtract this x equal to 3 from this range to get the final range of values of x, which would be satisfying this inequality. So the number of non-negative integer solution in this range would be 0, 1, 2, 4, and 5. So that means there are 5 non-negative integer solution which would be satisfying this inequality. Well, be careful whether we have been asked non-negative integer solution or positive integer solution, because in the non-negative integer solution 0 will be included, but in case of positive integer solution 0 won't be included. So based on the equation, our answer will change. So the number of non-negative integer solution which is satisfying this inequality would be 5. So in this way, we can find the number of non-negative integer solution for inequalities of high order curves. So that's it for today's video, in which we have seen some questions based on quadratic inequalities and inequalities of high order curves. But I would suggest you to practice some more questions, because the more you practice, the more you learn. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.